Hello everyone, my name is Marcos Managos and today I will be presenting you the results of my master thesis. My master thesis title was Extrusion of grass silage and its effect on feed intake, milk production and ingestive behavior of dairy cows. We have to say that forage from temporary place fed as silage is a major feed for Swedish dairy cows. Silage presents many advantages, including the minimized loss of nutrients, easier storing, handling, and feeding. However, as the maturity of the plants is increasing, so we have a decrease in digestibility, the filling effect is increasing, and these two limit the voluntary feed intake of the animals. This translates that for animals that they have very high production, we cannot cover their energy requirements on grass of high maturity, so we need to feed concentrates. By reducing the forage particle size, we may increase the rumen passage rate and hence increase intake. Extrusion is a mechanical pretreated method with many applications, including the processing of lignocellulosic materials on biogas production. Extrusion is characterized mainly by particle size reduction. Additionally, we have significant breakup of microfibrous crosslinks, which results in internal defibrillation. These actions result in increased substrate porosity, while they decrease the crystallinity of cellulose. On the diagram on the right, we can see a typical twin screw extruder. We have the motor, the hopper, the barrel, and the screws. As the screws are rotating, they are forcing the material to pass through the barrel. While the material is passing through the barrel, it is being subjected to thermal and mechanical energy, which causes alteration to its structure. The material is building up in the end of the barrel where it has to pass through a small nozzle, and this increases the temperature and the pressure. The moment that the material exits the nozzle, the sudden drop of pressure results in the water to vaporize, break the cell walls, and thus it makes the material more available for the microbes. Here we can see pictures of a bioextruder. On the picture on the left is the bioextruder that we used for the experiment, and on the picture on the right we can see the screw profile, how the screws looked inside the barrel. In this picture, we can see a very interesting comparison between untreated material, milled material, and extruded material. On the picture on the top left, picture A, we see rice straw that is untreated. Next to it, in picture B, we have milled rice straw, while pictures C and D are extruded material. Already we can note that there is a difference between material B and C, with C being more fine and it appears to have smaller particle size, while in picture D we can see how longer pieces of rice straw have been twisted by the action of the screws. Pictures E and F are pictures of scanning electron microscopy. Here on picture E we can see that the untreated material, the cellulose, has more smooth surface, so that translates that there is not enough surface for the microbes to attach and digest it. While in picture F, the material has been twisted, we have defibrillation, increased porosity, and thus there is much bigger available space, there is much more available area for the microbes to attach and digest the cellulose. So, moving on to the aim and the hypothesis. The aim of this experiment was to investigate the effect of extrusion on feed intake, milk production, and ingestive behavior of dairy cows. Our hypothesis was that extrusion will result in increased feed intake, improved milk production, without adverse effects on dairy cows' ingestive behavior. First, we will start with the materials and methods. Silage. First, we will speak about the silage production and processing. The silage was produced from the primary growth of a grass-dominated clay with a botanical composition mostly of timothy, which was 70%, and tau rescue, which was 26%. We had two harvest dates. So we had the first harvest, which we are going to refer to as early harvest on the 13th of June, and a second harvest, which we are going to refer to as late harvest on the 23rd of June. The grass was wilted to a dry matter content of 40 to 50% before it was ensiled in bales. During the experiment, the bales were opened, inspected, and then chopped into a vertical TMR mixer. Additive was added to increase the aerobic stability. Following chopping, we had extrusion took place, where we saw that we had a particle size reduction, we had a mix of the material, and also we had a slightly increase in the exit temperature, which was approximately 55 degrees Celsius. Here we can see a picture of the Penn State particle separator. It consists of three sieves with different diameters in the holes, and we use it to determine the distribution of the particle size in our chopped and extruded silage. Here in this slide we can see the chopped and the extruded silage. We can already see the difference in how fine the material is on the picture on the right. When we use the Penn State particle separator, we saw that for the chopped silage, the majority of the particles were withheld in the 8 mm sieve, while there was also material on the 19 and on the bottom pan, which was less than 8 mm. On the contrary, for the extruded material, there was no particles bigger than 19 mm, and the majority of the particles were withheld in the pan below the 8 mm sieve. Let's speak a little bit about the study design. The study took place in the Swedish Livestock Research Center in Lovsta, in Uppsala, between January and April 2020. For the experiment, we used 8 multiparous Swedish red cows, which were housed at individual tie stalls in a change-over design, meaning a Latin square. We had 4 fistulated animals and 4 intact animals, and the total experiment lasted 4 periods of 21 days each. 14 days of each period were used for the adaptation to the new diet, while the last 7 days were used for the collection of the data. We had a factorial arrangement of treatments, and the silage was offered either as processed or as control. Control meant chopped. As we mentioned before, we had two harvests, an early harvest and a late harvest, which both of them had very low energy content, with early harvest having 10 MJ metabolizable energy per kilo dry matter, while late harvest had 8.3 MJ metabolizable energy per kilo dry matter. Both diets are comparable in their NDF content, since it was approximately between 550 and 560 grams per kilo dry matter. Concentrate mix was also offered to the animals, with intact animals receiving 10 kilos per day because they were earlier in lactation, approximately 68 days, while the fistulate animals received a smaller amount of 8 kilos per day since they were later in lactation, with an average date of 143 days. We had separate feeding of concentrates and silage, and milking took place 2 times per day. Moving on to the results. One interesting finding of this study was that extrusion affected silage dry matter intake. As we can see on the graph on the left, extruded diets resulted in a higher intake of silage dry matter intake compared with controlled diets. There was a tendency in the interaction between harvest and treatment, and that's why we will focus on the main effects. So looking at the graph on the right, we can see that extruded diets had a statistically significant higher silage dry matter intake, which was approximately 18.5, compared with the intake of controlled diets, which was 16.6. The difference in the silage dry matter intake affected also the milk production. Both the milk yield and energy corrected milk yield were affected by treatment, and there was a tendency towards interaction between harvest and treatment. That's why in this slide we will focus on the main effects. On the graph on the left, we can see that the extrusion increased milk yield. So animals consuming extruded diets produced 32.9 kilos of milk per day, compared with animals consuming control diets that produced 31.5. Energy-corrected milk yield was also affected by treatment. Energy-corrected milk is a term that combines the milk composition, and more specifically the lactose content, protein and fat content, with the milk yield. So we see that in this graph, animals consuming extruded silage produced 36.8 kilos of energy-corrected milk per day, compared with control diets that produce 35. This can have potentially economical benefits for the farmers. In this slide, we can see more information about the milk production and more specifically about the milk composition. We can see that extrusion resulted in a numerical increase in the fat content of the milk. However, this difference was not statistically significant. Protein content was statistically significant higher in animals receiving extruded diets. This number combined the slightly numerical increase in the fat content and the statistical significant decrease in the protein content combined with the increase in the milk yield resulted in a higher total production of fat and protein as grams per day in the animals that received extruded diets. This has a potential economic effect for the farmers since they can increase their income. Moving on to rumen pH. Rumen pH was slightly different between treatments, with animals receiving extruded diets having average rumen pH decreased by 0.1 units. This small difference in the average rumen pH can be explained by the decrease in the physical effective NDF intake. Physical effective NDF is a term that combines the NDF content of the diet with the particle size of the diet. So it makes sense that since we decrease the particle size, we expect also the physical effective NDF intake to decrease. However, when we combine the two treatments, we see that the area below pH of 5.8 does not differ significantly between the diets. The cutoff point of 5.8 is considered to be a critical pH limit under which the fiber digestion and the rumen environment health is being compromised. Finally, we can speak a little bit about the ingestive behavior. In this slide, we can see that eating time decreased on animals consuming extruded diets. Combined with a higher intake, we can deduct that the eating rate increased, meaning that the animals consumed more feed in a smaller period of time. Rumination time also decreased, and this can be explained by the decrease in physical effective NDF, since the material was passing faster through the rumen and it was not providing the stimulus for rumination. Since eating time and rumination time decreased in animals receiving extruded diets, so we had an increase in the idle time. The conclusions. We can conclude that extrusion of silage will result in an increase in silage dry matter intake, meaning that we will be able to use more forage in the diets of dairy cows. It also increased milk production with potential economic benefits, and we are expecting that these two phenomena will decrease the human-animal feed competition, since we have animals that are consuming more forage and are producing more milk. Finally, we noticed that there is a slight decrease in the average rumen pH, but we didn't notice any abnormal effect in the behavior of the animals or their intake to suggest that their rumen environment had been compromised. All in all, we can conclude that extrusion can contribute to a more sustainable animal production. However, since there are not many studies on this topic, there are possibilities for future research that include the effect of extrusion on microbiota, rumen microbiota, or to investigate more the physical changes that happen in the material as it's being processed. That was my presentation, and thank you for your attention.